Our final two graphs are a little bit different than a lot of the graphs that you've seen. The first is a time series graph. And so you can see here that on the horizontal axis, we're charting weeks. And so let's say we're training and we're swimming in training. And then on the vertical graph, it's how many miles that we're swimming in that particular week. So if we're tracking this, we can see that we swam about 1.5 miles in week 1, and in week 2 we swam about 1.4 miles, but a little bit more. And then here finally in week 20 we were swimming about 2.5 miles in that week. Okay, and so for this, in this time series graph, you could either have left them as individual dots without the connectors, or like it's showing here, you could connect the dots. And so this is a case where you have numerical data, and it's similar to a scatter plot in that all the dots represent the combination of what week and how much the distance that you swam in that week was. This is not the same as a scatter plot, and we'll be working with scatter plots later in the year that have two numerical variables, and those you would not connect the dots. In this one it's completely appropriate, but when you're connecting them, they have to be going connect week 1 to 2, 2 to 3, 3 to 4, and so forth all the way. You can't kind of connect it across and then back. And it's always from all the way across the horizontal axis going in order. So that's a time series graph, and we can kind of tell some things from this. On average, not every week, but on average we tend to be swimming more than we did in the past. And so that's the trend line. Even though that's not happening every week, we can see here between weeks 14 and 15 we swam a little bit less in week 15 than we did in week 14, and it's not uniform even when we're swimming more. So that's a time series graph, which is telling us something. And then this last thing called a cumulative relative frequency graph, or an ogive. So what this information is on the horizontal axis is call length, and so this is a call center, and they record the length of every customer service call that comes in. And then it's the cumulative relative frequency. We saw cumulative relative frequency in our original frequency chart. And so at the far left of every ogive, you're going to have 0 cumulative frequency. You're going to start, so you haven't collected any information yet. And at the end, you're going to be, at the right end, you're going to be at 100% every time. So this is in 3-minute increments, and so it looks like for the first minute, they got about 1% of all of the call lengths lasted between 0 and 3 minutes. Then about the same frequency, about another %. And the flatter this is going, the fewer things that you're getting in that, in this case, time period. And so another %. This looks like a little bit more, maybe about 3 or 4% lasted between 6 and 9 minutes. And then looks like about maybe 10% of the calls lasted between 9 and 12 minutes. And so the steeper that it starts getting, that's where the more density is, where more of the calls are coming from. And this looks like it's one of the most popular time areas, is from 12 to 15 minutes, because it looks like about 20% of the calls were 12 minutes or less, and about 40% of the calls were 15 minutes or less. So that means that difference, the difference between 40% and 20%, that about 20% of all of the calls coming in lasted between 12 and 15 minutes. And so it looks like very few were happening here in that 21 to 27 minute range, and then it started getting steep again, and then not many more than like 39 minutes. So that's called an ogive. And so there's two things we can really tell from this. Trying to put a couple things on here. One is if you're asked to find a certain percentile. So at what percentile is called a 21-minute phone call. And so to find so you would start at your 21 minutes and go vertically from there till you hit the graph. And then to find the percentile, then you would go straight across from there. And so we could say that a 21-minute phone call is about at the 60th percentile. In other words, about 60% of the calls are fewer than 21 minutes, and about 40% would be more than 21 minutes. Okay. The other thing is, if you were to be given a percentile, you could find it by going the opposite direction. For example, if we were asked, what's the median call length? Well, what I could do is I could go here to the 50th percentile, which is what the median is. Half the calls would be longer and shorter. Go across until I hit the graph. And then when I hit the graph, then I draw a vertical line. And so now I can say, oh, it looks like, I don't know, about 17-minute call length is about the median call length. And you could do that again. Well, what would be, what are the upper 20%? Well, that would mean I'd be in the 80th percentile if it's the 20% of calls that are the longest. I'd go to the 80th percentile. I'd go straight across until I hit my graph. And then from there, I'd go vertically. And so I said, okay. So I'd be able to say, well, about 20% of the calls, more than 80th percent, last from about 32 minutes or more. And so you can tell that from the Ogive. So you can either, given a call length, figure out what percentile that's in, or if you were given a percentile, you could go across and figure out what that call length was. And so it's not used a lot, but and you'd never be asked to make one of these. You would just be asked to interpret it. Okay, that's it for our numerical displays of data.